Okay, you guys, I wanted to make a little video for you today because I've had several questions about putting together these ions and making ionic compounds. And so there's still a little bit of confusion. I know it's hard to figure it out on your own, and it'd be nice if we had class all together where we could work this out. I made these little puzzle pieces as a model for us. And so I think if I demonstrate this for you, I think it'll click with some of the questions that people have had about how do we balance the charge? What does it mean to make them equal? So take a look at my pieces. These orange pieces are my cations. Here's a sodium plus 1, calcium plus 2, aluminum plus 3. What do you think, what do they have in common? And what do you think that represents about that atom? Can you tell? So this is a sodium plus 1 cation, 1 positive charge. It has one little V-shaped indentation there. And then these are I've got some more plus 1s over here, but these are my anions. There's a fluoride. Remember the ending changes to "ide" for your anions. And this is a -1. My oxide is a -2. My nitride is a -3. And so the whole goal in writing correct compounds, writing correct formulas, is that the charges have to be balanced. If I have one positive charge, I have to have one negative charge. And so I can put some of these together pretty easily, right? And I can see that that works. That makes a nice little puzzle. And this would be 1 sodium, 1 fluorine, and it would be sodium fluoride. Its name, you say the name of the cation, and then the name of the anion with the ending change to "ide." Okay, same thing with my +2 and my -2. My +2 calcium cation and my -2 oxide anion. And so that fits together as well. And so it'd be 1 calcium to 1 oxygen. CaO. We don't have to show the ones, they're understood in the formula. And its name would be name of the cation, calcium, name of your anion with the ending change to "ide, so calcium oxide. And then one more time, let's do it with our +3 and our -3. So aluminum is +3, nitride is -3, so Aln. Because the charges are already the same, they're already balanced. I just stick them together. And I don't show any charges at all in my overall formulas for my ionic compounds. Aluminum, what's the ending for this one? That's right, nitride. Nitrogen becomes nitride. Okay, so now let's shake it up a little bit. What if instead of my fluoride, what if I want to stick sodium with oxide? Well, doesn't work, does it? What's the problem? Well, my 1 positive charge on sodium can balance out one of the negative charges. We could think about each one of these little poking out pieces, these little protuberances here. We could think of each one of those as having a negative charge. In fact, that really makes sense because how does oxygen become an anion? It gains electrons. And so oxygen had to gain 2 electrons to become oxide. So negative charge here, negative charge here. Well, what's the problem with this formula? If I just have 1 sodium and 1 oxide, my charges don't cancel out. I need one more positive charge. And so I need another sodium atom. And that's the only way to make the charges equal. I need 2 plus 1s to balance out the -2. And so my formula for sodium oxide would become Na2O. I needed 2 of my sodium atoms, 2 sodium cations, for every 1 oxygen anion that's there. So 2 sodiums. And we looked at doing the little switchy thing where you can take the charge on your cation and your anion. And really doing the switchy thing is really just a way of finding the lowest common multiple. Well, between 2 and 1, that's pretty easy, right? +1 - 2 I'm going to get my charges to 2 overall, so I need 2 positive charges and 2 negative charges. I've already got 2, so that'd be 1 oxygen would give me my 2 negative charge. If I have 2 of these sodiums, that's going to give me my 2 positive charges to balance out with my two negative charges. And we can see that visually with our puzzle pieces. I wish we were in class because I have a whole big bag full of these pieces, and it does make it easier when you can hold them and manipulate them yourself. You can cut these out. I could actually send you guys the template if you want to. This is not quite the same as the template I have in my classroom, but it's one I just made for you guys when thinking about answering some of the questions I've been getting. All right, so let's try one a little harder. What's the compound going to be between calcium plus 2 and nitrogen minus 3? So my calcium cation, my nitride anion, plus 2 and minus 3. Well, if I stick another calcium on there, right, if I move that, put a second one right here, well, I'm going to end up with an extra positive charge. How am I going to make sure that every dent and little pokey piece, how am I going to make sure that every puzzle piece has something to match with it? Well, I've got to figure out the formula, the correct formula. I've got to make these charges balance. So between plus 2s and minus 3s, calcium can only come in plus 2s. I can't change that. I can't just put half of a calcium here. And my nitride can only come in minus 3s. So we'll do it a couple of different ways, and we'll look at it. So if I take 3 calciums to every 2 nitrogens, just taking the charges and turning them into the subscripts, that gives me the correct answer. But that may not help you understand the why. What we're doing here is finding the lowest common multiple between 2 and 3, which is 6. And so I know that I'm going to need 6 positive charges and 6 negative charges, because that is the lowest common multiple between my 2 and my 3. My 2 on my cation, my 3 on my anion. This only can come in multiples of 2, only comes in multiples of 3. All right, so my calcium plus 2, how many of those do I need to give me a plus 6? Well, I would need 3 of those, so times 3. This is a separate way of thinking about it than switching the charges. My nitrogen with its 3 negative, what can I multiply it by to get to negative 6? I'm going to multiply that by 2. So negative 3, 2 of those taken twice gives me negative 6. Positive 2 taken 3 times gives me positive 6. And now the charges balance. If I take 3 calciums and 2 nitrogens, then I don't have another nitrogen piece. But you can visualize it in the background here, right? And then another calcium would come to right here. And then a third calcium to the end. I don't know if you can visualize that, or if you want to go cut some paper and figure it out. All right, so you try this one. What if I take my aluminum plus 3, we'll take him, and let's take fluorine. That one's a little easier to see, isn't it? How many fluorine atoms am I going to need here to fill all those spaces on my aluminum cation? So I've got an aluminum plus 3. I have a fluoride minus 1. The only way that I can make those charges the same is pause it, think about it, figure it out. But I'm going to need 3 of these fluoride anions. I'm going to have 1 here, 1 here, 1 here. And so when I do that, my charges will be balanced. And the formula would be AlF3. And the name would be aluminum fluoride. Okay, I hope that helps clear up any misconceptions or misunderstandings that you guys are having. I hope that clears up any confusion. Please keep sending me questions. I'll be happy to. If y'all want to do another Zoom meeting today, or if you just want to send me your direct questions, either way, it's fine with me. Bye, y'all.